If you watched my video on single replacement reactions, you saw that in a single replacement reaction, a single element is taking the place of some other element in a chemical compound. If you understood that, then you understand double replacement, I think, fairly easily. Here it is simply. A double replacement reaction is where you have two compounds. I'll just cover up this part. You have two compounds as your reactants. And the two compounds they're going to be, in all of the examples in my class, they're all going to be ionic compounds of some form or another. In the two compounds, you have a metal and a nonmetal, metal and nonmetal. And so what's going to happen in the double replacement reaction is the metals are going to switch compounds with each other. So the metal from the first compound is going to go and join with the nonmetal from the second compound, and the metal from the second compound is going to go and join with the nonmetal, or the negative ion, in this case polyatomic ion nitrate, in the first compound. So AB plus CD is going to produce AD and CB. Let's look at it. So, silver nitrate becomes silver chloride, and potassium chloride becomes potassium nitrate. It's a double replacement. In the single replacement, a lot of times it's helpful for students to think of it as somebody coming up and saying, "Mind if I dance with your date?" And the single element takes the place of one of the compound elements, and the compound element gets kicked out and becomes single itself. Mind if I dance with your date? In this case, it's like two couples dancing, and they just do a dance partner swap. So the silver and the potassium just switch partners, and that's what your new compounds look like. Someone asked me, will the silver join with the potassium? No, typically not. Those are the plus charge ions, and so they're going to not seek another plus charge ion. They're going to seek another negatively charged ion to join with, so that wouldn't happen. Combustion reactions. The fifth type that my class needs to know is a combustion reaction, and combustion is just another way of saying burning. Particularly in my class, all the examples are going to be where some hydrocarbon, and that is a compound made of just carbon and hydrogen. It could also be a carbohydrate like sugar, but in this case it's all going to be hydrocarbons. Some hydrocarbon is going to join with oxygen, they're going to react, and your products are always going to be carbon dioxide and water. So from here over is always going to look the same in a combustion reaction. The question is, what's that original compound that's joining with oxygen? I have X's in the subscript places for this hydrocarbon because hydrocarbons can be all kinds of different combinations of carbon and hydrogen. So I just put X's in. Here's one example I went and found on the internet. So in this case, what you have is methane, CH4, 1 carbon, 4 hydrogens. It's just one of the many possible combinations. You have oxygen here as diatomic molecules of oxygen, and the product is carbon dioxide and water. So that's just one of many examples that are possible for the combustion reaction. Combustion always produces light or heat and light, and is always going to result in carbon dioxide and water.